Technical processes can be roughly divided into industrial processes and discrete parts manufacturing. In industrial processes, liquid, solid, or gaseous materials are produced by biological, chemical, or physical processes. Serious danger is often involved in industrial processes, such as the risk of explosion or contact with poisonous substances. Safety is therefore a major aspect in the automation of such processes. Generally, an industrial process must not be interrupted, and it is often difficult to predict exactly how long it will take to produce the product. Discrete parts manufacturing creates production lots of a product, such as screws or automobile bodies or bottle filling. They are normally mechanical processes. The main emphasis here is on throughput and speed. Both types of process can be further divided into the categories manufacturing processes, distribution processes, and storage processes. Processing in industrial processes includes, for example, chemical reactors, as used in the chemical or pharmaceutical industries. Processing in discrete parts manufacturing can be found, for example, in turning shops or in rolling mills. Distribution in industrial processes typically makes use of tankers or pipelines. In discrete parts manufacturing, distribution might involve assembly lines and packing machines. Storage in industrial processes includes, for example, tank farms or silos. In discrete parts manufacturing, for example, high-rack warehouses. Within industrial processes, a distinction is made between continuous processes and batch processes. Some of the feature differences can be illustrated using an example. A vaporizer is an example of a continuous process. A group of stir tanks is an example of a batch process. A continuous process produces large amounts of a product in a continuous product flow. The longer the process runs, the more product is produced. A batch process, on the other hand, normally produces comparatively small amounts of a product in a discontinuous process. A continuous process produces only one product. A batch process is often used to create several different products. As a basic principle, we can say that the main aim of a continuous process is to maintain a steady operating state in each unit involved in producing the product. While in batch processes, various different states may be required at different times in a unit to produce a product. For example, heating, stirring, and cooling are process actions that may be accomplished in the same unit during a batch. In a continuous process, the know-how is in the process controls and in the resulting automation solution, while in a batch process, the recipe contains the essential know-how for producing the product. At this point, we have seen that industrial processes can be classified as continuous and batch processes, and we have looked at the major differences between them. If a batch process needs to be automated, the first question that arises is whether or not the use of a batch system will be beneficial. Based on the following 6 criteria, we can find the answer to this question simply and objectively. The use of a batch system is indicated when the same set of batch equipment is used to produce many products. When production activities are often extended by adding new products or replacing old products. When production activities are frequently being optimized. When production activities and all the variables influencing the product need to be logged. When it is necessary for operating personnel to be able to create or modify production activities. When it is necessary to be able to dynamically allocate equipment to a batch. The more criteria met, the more likely that a batch system will be the best choice. Batch management software is frequently found in manufacturing, biotechnology products, pharmaceuticals, paints and varnishes, fertilizers and pesticides, food and drinks, detergents and cleaning agents, plastics and adhesives, chemicals and mineral fibers.